My name is Tiffany Freeman. This is my PLC video, and I am meeting with the 8th grade math department. Thank you all for being here today. Welcome to PLC. I'm going to start by remembering our norms, right? Start every meeting this way. So remember to be present and engaged in our conversations. Assume positive intent, especially as we look at data, right? This isn't a gotcha or anything like that. It's all how can we be better for our students. Maintain a growth mindset and stay solution oriented. We don't want to be having any blame or anything like that. We want to honor all voices and then follow through on any commitment. So if you say you're going to do something at the end of this meeting today to address any of the issues we may uncover, make sure we follow through on those things. Maintain professionalism always. Y'all are really good at that. And then celebrate successes. And adding in and leading into that celebrating successes, we're going to start our meeting like we always do. Does anybody have any good things they would like to share?
My good thing is that my husband and I, we got unloaded into our house, so we're like unpacking a lot. And so as a reward, yesterday we decided to put out a Christmas tree and start our Christmas spirit. And you kind of fed me that because y'all got in the Christmas spirit, which was nice. So yeah, that's my good thing. We got to have like a festive home, and we have a little village out and our trees. So we're just happy when we get home, which is nice.
That's awesome. I really want to get a Christmas village for one of my bookshelves, but I've been told I need to wait till next year, so.
Wait till Hobby Lobby sale happens.
It's happening.
No, I want to go to they have like a Christmas store in Fredericksburg I want to go to.
It's awesome. Yes.
Anybody else have any good things?
My birthday's in 2 weeks, and so this weekend going to Dallas to go to the Mavericks game, and they fired Nico Harrison, and that was the highlight of my week, I think. I hate him with a passion.
Not in line with staying positive, but I'm happy for you that you are going to the Mavericks game.
Yes.
I have one good thing. My son, who's 7, was like, he wanted to go to literacy night at the middle school last night. And I'm like, you know what literacy is, right? It's like reading and writing. He's like, yeah, let's go. I said, he wanted to go to the book fair, pretty much what he wanted to do. But I thought it was cool. I hit a deer on the way there, which was bad. But he's like, Dad, can we please still go? I was like, yeah, let's go. So it was cool. I was excited for him that he wanted to go do that.
That's awesome. Congratulations. I'm glad that Doss wanted to go to literacy night, and I hope you found some good things at the book fair.
That's cool, yeah.
Okay. Thank you all for sharing your good things. This is what we're going to be doing today. So for our agenda, we are going to look backwards first, and we're going to see how did your current students do on the 7th grade TEKs that are related to volume, because I understand y'all are starting your volume unit. So we want to look at how did they do on those kinds of questions, even if the TEKs are not fully related, right? Like your TEKs are covering more of those round shapes, whereas in 7th grade it's more prism based. And then also looking at how did y'all do teaching this TEK last year? How did your kids perform on last year's 8th grade math STAR test? Okay. Then we're going to look ahead and talk about how can we anticipate and pre-plan for those misconceptions that you think are causing them to maybe not perform so well on this topic, and how can we intentionally support our emerging bilingual population. Our EB population as a district has increased a lot in the last 5 years or so. I know at the high school, the amount of EB students in the last 5 years has more than doubled, yet we have the same amount of staff. So we know the state has the push for content-based language instruction, so we need to start supporting that, because the intention is that within the next 3 years, every teacher is incorporating those into their classrooms, the ELPs, all that kind of stuff. Okay? Any questions about our agenda? Okay. All right. We are going to start by looking at some 7th grade STAR data. So the TEK that vertically aligns to the 2 volume TEKs in 8th grade is TEK 7.9a, which is I can solve problems involving the volume of rectangular prisms, triangular prisms, rectangular pyramids, and triangular pyramids. The TEKs that y'all address in 8th grade math are solve problems involving the volume of cylinders, cones, and spheres. And describe the volume formula of a cylinder in terms of its base area and its height. So that 7th grade TEK is a readiness standard, so is the first 8th grade math TEK, while the describing the volume formula is a supplementary. So we want to make sure that we are addressing those readiness standards. Now, your current students last year on TEK 7.9A, as a campus, we're at 43.79%, and that's campus-wide, right? If you look at the breakdown, we can see that our emerging bilingual population is performing significantly lower than the whole campus, right? When we look at the question by question breakdown on this, it actually gets pretty interesting to where our emerging bilingual students outperform on certain item types, but then the more wordy ones they really struggle with, which is natural.
That makes sense, yeah.
But a statistic I don't think we always look at when seeing this data is this includes all of Michael's Algebra 1 students because they took the 7th grade Math Star last year.
Oh, wow.
If we remove those students, they were only at 29.27%. So your current 8th grade math students that are not taking Algebra 1, less than 30% of them mastered this TEK. So
Mastered, not approached or anything like that?
well, I mean, it's just by question, it's by
Okay.
by standard, so less than 30%
Got it
got it
Right, okay,
essentially,
gotcha.
and there were, I believe, 2 questions. So in
What
those,
does that mean about Michael's?
so all of his students that are in Algebra 1,
So does that mean,
we're bringing up the average. So if you look at your actual students taking 8th grade math, only 29.27% of them,
so his were even like 50%.
yes.
Yeah.
I believe when I looked at just the kids in Algebra 1, it was right at 60% of his students. So volume as a whole was low in 7th grade math last year, but when we desegregate it like that and look just at our current students and remove the ones that are now in that advanced class, the data gets worse essentially. Which this tells us we have some misconceptions to address. They didn't fully understand volume with those more simple shapes, and now you're moving into cylinders, cones, and spheres, and some of the questions are in terms of pi, some of them are as a decimal, so there's a lot more facets to that than just triangular prisms, rectangular prisms, that kind of stuff.
Okay.
So the benefit, I think, is that all of your shapes are round, right? And even though the 7th grade ones use essentially the same formulas, I think there's more variation, right?
Yes.
So moving forward, you should keep those things in mind.
Yeah.
Okay, so we're gonna look at some of the 7th grade questions. I apologize, this is a little small. Okay, so this question was on the 7th grade Math Star last year, so your students had this. It asks, a chocolate bar in the shape of a triangular prism is shown. What's the volume in cubic centimeters? So looking at this, yes, you are correct, it is D. But before I show you how your students did on this specific question, where do you think they might go wrong?
Probably.
They don't need that 13.
Yeah.
So like they give them extra numbers. I'm sure some kids are like, I gotta use them all somehow. So
That's what I was gonna say. The area of a triangle is where they messed up.
Yeah.
Maybe the height is where they messed up too, because
Yeah,
they probably thought the height was 12. Some of them, you know.
They forget to plug in that big B with the actual area equation, so it's our formula. So it's it gets tricky because we repeat that over and over again.
And does
Big
this
B.
relate to what you're currently about to teach them?
Yeah.
Area, yeah.
Yeah, because we teach them how to find the area of the base. I mean, talk about how the height. I was telling them, like, if I'm 6 foot tall, if I'm laying down, how tall am I? Well, I'm still 6 foot. The height is the distance from my head to my feet. So it's the distance between my triangles. It's not always
Distance from base
the
to
vertical
base.
height. Yeah, it's always the distance.
Yeah.
But I mean, and I can say that a million times, but
Yeah. I think also with the triangle specifically, there are 2 heights. You have to find the area of the base, which is the height of the triangle, and then the height of the actual prism, which just, it's mind blowing to them. It's hard to grasp.
Anybody
Maybe
want
we
to take a guess on how your students did on this question last year?
Current
12%.
8th graders?
All 8th graders,
All
not
8th graders.
desegregated between 8th grade math and algebra 1.
50%.
Yeah, I'm
I'm
going
with 12.
27.
22%
Ooh.
of students got this one correct. Majority of kids picked C. So what mistake are they making if they're choosing
They're not
One
dividing
half.
by 2.
Yeah.
They didn't divide the triangle by 2.
Wow. Well, what's cool though is that they did some of it correctly. They just forgot that 1/2 portion.
And there's that 62%, you know what I mean?
Yeah. Yeah, total that would be the 62. Yeah.
Yes.
Dang.
So
they're
really,
close.
36% had no clue.
Yeah.
That's what I think the 13.
37.
Well, those ones I think they used the 13 instead of the 12.
Instead of 12.
And so then same thing. If they're picking A, they did it correctly, but using the 13 instead of the 12.
Oh.
And then if they picked B, they used the 13 instead of the 12 and did not divide by 2.
Yeah.
So lots of steps there.
Yeah, there are a lot of steps.
Yes. So the other 7th grade question is this. So we have a rectangular pyramid
Any? Oh man.
and ask for the volume of the pyramid.
Let's see. Right, 'cause it's
Yeah,
1/3 base times height.
Yeah.
So so how many got that right?
This one seems more straightforward.
It does.
Right.
I'm going, it does.
I know you're trying to do the math from the previous screen. Okay.
I'm going
34%.
31.
36.
That was good.
36. And they're split mostly between B and
60%
D.
had a clue again, yeah.
Yeah.
So what you're saying is they know what to do, they're just missing those final steps, right? On this
Yeah.
one, the divide by 3, on the other one, divide by 2.
I don't know how they get A or B. I'm just trying to figure that out. Sorry.
Yeah.
Trying to figure it out.
Trying to figure out how they would get A or B,
So that,
because that's a good. 38%.
Do we think they're not using the right formula?
I think they found the perimeter of the
Mm.
base and multiplied it by 9. 'Cause the perimeter is 38 times 9 is 342.
Perimeter of the base times the negative.
And then if they divide it by 3, that's A. That's the area of the base.
Oh.
I think where a lot of them struggles, they struggle to decipher between volume and surface area.
Yeah.
Surface area, we find
It's
the perimeter.
perimeter.
The area, we find. So I mean, and that's why in 8th grade they struggle. So we do volume now. We don't do surface area till January or February. So I keep them very separate, just so they don't mix it all together.
Gotta keep it separate.
I know, my initial thoughts, it's making me want to just which formula should you use to solve this? Forget the answers.
Yeah.
You know what I mean? Pick the formula that you should use. And there's a picture of the formula chart. You just
Yeah.
click.
Yeah.
And looking at these were the two questions. Looking at these are the two questions that our current 8th graders took in 7th grade, and knowing that our emerging bilingual population performed very low on these two. Is there anything you think that is specifically throwing off that population? I think this question is less wordy,
Yeah.
right? It says that word pyramid, which is what it's gonna look like on their formula chart as well.
Yeah. It says
And
volume.
then if we look at that previous question again, it says triangular prism. It says the word volume. So what might be throwing off our emerging bilinguals?
I think it's the same thing that kind of happens with our non-emerging bilinguals. There's so many steps that they have to apply to it, and because there may be some type of language barrier, they're not catching all of the steps.
I know, because I wonder what percent is emergent bilingual? Do you remember?
It was like 29.
They were at 29.
29% of them.
Yeah, but our overall was also
29.
29. So I mean, it's not a whole lot of difference.
Unless some of that 29% of emerging bilinguals is
And
yours.
algebra, but I don't have that many.
Yeah, so
It wouldn't make a big
that
difference.
like tells me they're doing the same.
I was like, they're
Almost
about
as
they're on
many
par
cars.
as everybody else. Like, there's not a lot of difference to it.
But I think that's a good point though, I think too, because it's like, okay, if they're both struggling on it, it's like, why are they struggling?
Yeah.
Why are they struggling?
I like what you said earlier. I wrote it down. Like, which formula should you use? Like, and the last year we didn't do that. We had the formulas out.
And we
front of us.
practiced
We
using the
that
formula.
one. But maybe if we mix them, or even like our entrance that we do, or our warm ups, like which formula should you use? That would be something that helps them decipher. Once they learn both options.
Yeah.
Like, I always start mine with just like, we're playing the look at just like, what shape is this? Is it a prism? Is it a pyramid? Is it triangular prisms? Like, just so they can find the right shape, and then, alright, it says volume, so I gotta go to volume, and I gotta go to that shape, and that's the formula I gotta use.
Yeah,
Like,
dude. I even think like even simpler than that, because they're gonna give them the name of the shape.
yeah.
They're gonna give them the name of the shape. They're gonna tell them what to do. So it's like, can you click on the formula that you're supposed to use? You know what I mean? It's like
Does it say the shape in the other one too?
It
It
did
did.
say triangular prism.
it says it in all of them, I think.
I believe it does.
Yeah.
And on their formula sheet, it tells them where that's at.
That big B,
It throws them off.
it gets them. But
So knowing that last year, it appears that they struggled with knowing the parts on the 3D figures, right? The difference between area of the base and perimeter of the base, the difference in the height of the triangle versus the slant height of the prism. How can we support them knowing that they're coming to us with that misconception? Even though it doesn't directly apply to the volume of the cylinders, cones, and spheres, it kind of does, right? They're gonna need to know the difference between radius and diameter, the difference between area and circumference, all of those things.
And like, I mean, at some point we're also gonna do surface area. So they're gonna do
Yes.
the perimeter of the base rather than the area of the base. I feel like hitting hard big B, like what is big B? What is big B? What is big B? Like, it's for me, I go, oh, cylinder's just pi r squared times height. Just having you and like, it is, but then like, they need to know big B. Like, I gotta start hitting big, I know Chris is a lot better than me than that. Like, big B times H, I'm like, oh, it's just pi r squared. But then when we do surface area, for like, it just says 2B plus BH, whatever.
Yeah,
BH
it's a
plus
lot.
2B. And they're like, what are all these letters? I'm like, no. If we would have like practiced it forever, big B is area to base, area to base, area to base, like, I feel like that's where we struggle. Or that's where I struggle.
You already look now at the 8th grade data. Okay, so this is how did y'all do on 8th grade start, and I looked at 2 years of data. Okay, so this is the 2024 test and the 2025 test.
Numbers
Okay.
combined.
They wouldn't be combined because the
Okay.
Algebra 1 kids don't take this test.
Okay.
Okay, so this is just 8th grade math students. So your readiness standard is that 8.7A. Last year, only 33% roughly, okay, versus in 2024, 59%, okay?
Wow.
And in 2020, and then on the not readiness standard, right, the supporting, we had 62.5% last year versus 79% the year before. So we had a dip last year. Now, we like to track cohorts of students, right? So I did go back and I looked at that 2024 cohort. How did they do on their 7th grade math star the year before that? And their scores were not this much of a difference compared to the following year. So it's not just that that cohort was better performing, okay? So we need to look at what may have happened, and then also like how can we support in that readiness standard, because they're performing better on our supporting versus our readiness. Our emerging bilingual population, again, in 2025 it was lower, right? They were at 23.3% versus that 33%. Was not an issue in 2024 on that readiness standard. The emerging bilingual population was equivalent to the whole campus. And then on the supporting standard, the emerging bilingual population actually outperformed the campus as a whole last year. So that's a celebration, right? But we have to figure out what's going on with the readiness standard that's solving problems involving the volume of cylinders, cones, and spheres. So do y'all see any other ahas or anything on this screen before we look at individual questions?
No, I'm just digesting.
It's a lot to take in.
Like my first thought is, alright, how was this question different than the year before?
Yeah. I almost want to see the questions the year before.
Okay. I don't have those in the
No, I
presentation, but I
understand.
can pull them up very easily for us.
So do the 2025 question.
I do have the 2025 questions, so let's go ahead and look at those. So this is for TEAC 8.7a, the readiness standard. Okay, so last year, sphere has a diameter of 6 centimeters. What is the volume of the sphere in cubic centimeters in terms of pi?
That's why in terms of pi.
So a little over 38% getting the correct answer here.
That's why.
It is in terms of pi.
So I mean, there's no shape, they give them the diameter, and they want it in terms of pi, like,
They have to switch.
Yeah. And you know how many times I taught in terms of pi? 0. That's why.
Okay.
Yeah.
0.
cause I'm like, cause in the real world, why would I, what's the answer? 36 pi, I'd be like, well, no, like, I'd actually solve the answer like,
Really, we did.
like, it says solve problems involving the volume of cylinders, cones, and spheres. It doesn't say solve it or in terms of pi. Why would you ever? I just understand why that's even a thing. Like,
So I can actually answer that
Oh.
in terms of testing, right? So if you look ahead in that vertical alignment piece, SAT, PSAT, ACT, and TSI, the majority of those questions that involve circles are in terms of pi. Because then those answers are exact. Versus a rounded answer. There's also more variation when you have to tell them use 3.14 as pi, which causes misconceptions because then students believe pi is 3.14 versus, that
Extended,
non-terminating decimal. So longevity wise, they're going to see it in terms of pi more often than not.
well, that's good to know.
Moving forward.
Yeah.
So you already said,
We don't
Yeah,
really
like-
teach in terms of pi.
Yeah.
so is that something that would be easy to address?
Definitely.
Could you have them
Yes.
set up the formula, simplify that one part without the pi, and compare both answers?
And really, it's one less step that they have
So I
to
feel like
apply.
just don't push the pi button on your calculator.
4/3 R cubed. Bam.
Yeah. So that would actually be easier to teach.
And
Yeah,
if
but
They still have the other
you're talking
option.
about all that stuff from last time. What's the area of the base? I mean, pi r squared would be an answer to area of the base, right? So pi, well, not on this
R
shape,
squared,
but
yeah.
I'm thinking about like
Cylinder.
that is what I focus on a lot. Is like, what is the area of the base? 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 But this is a sphere, so it's a little different. But it's like, I never like, I don't know. And if you do look at 2024, it's what's the volume of the sphere
Yeah, really.
with the diameter 13, and it gives you the sphere, and it's not in terms of pi. It's just
but both
what's
of
the
them
answer.
are giving you diameter. So is that
Both of them
something
are
we're
diameter.
focusing on?
Yeah.
We practice that a lot.
Okay.
Yeah,
We're doing
diameter
that.
versus radius. Yeah.
So I'm like, if you see the diameter and you use it, you die.
Yeah.
You told me that earlier. Bus job.
I'm gonna write that down.
There you go.
Diameter, you die.
Another Levinsism.
Yeah.
But yeah, that's something like I could like. To me, it's like that is so stupid. You know what I mean? To me, it's like okay, there's one more thing I gotta do, but it's one more thing I gotta do. It's like it's one more thing I gotta do.
It's an easy tweak.
It is,
Right?
Yeah.
I know at the high school in the geometry classes to support SAT, this is something that they've started doing a lot more as well
Yeah.
in the circle unit and even in special right triangles, like leaving it in terms of an answer with a radical. And so it really just supports them long term if they decide
Yeah,
to go
I mean-
down that college track.
I'm on board with that.
And it's an easy fix. Like it's just like making like an additional step. Like let's write it as 12 pi, and then now what's the actual answer?
They did have one on 24 that was a cone in terms of pi.
Do we also think showing them that breakdown of, instead of just typing the entire thing into their calculator and showing them how the numbers simplify down to, in this case, that 36 before you hit the pi button, can also help with their mathematical reasoning?
Yes.
They're building better connections with simplifying expressions.
I mean, I think that's cool. Like, I think the thing that to hit home for them is like, look, pi is a number that goes on forever. Like, you can't like, it's like space. You know what I mean? It's like infinite number. It's like, so why type it in at all? You know what I mean? So like, when you guys go to high school, they're not gonna make you type that in because it doesn't make sense. Pi is a number that's just crazy. So why don't we just leave pi out as, type the rest of it in, and see what the answer is, and then we can put that answer. I think that would make sense, just telling them the truth. You know what I mean? Like, you know, but like you said, it kind of goes against the grain of what's big B mean and what's
Yes.
area of the base and what's perimeter of the base. It goes against that. So it's like those two things are, it's two different things. It's just two different questions. And I think like if we start treating volume like two different questions, like, all right, let's find the volume. Let's know what area of the base is. Let's know what the height is. But let's also know how to write this a little easier. I think that would be fine. I think that would just be something like, let's make it make some more
Unless
sense.
something has changed from when I was on an item review committee, this is the direction that STAR is moving.
Okay.
When we are reviewing questions, they're looking into, do kids understand it conceptually as well? And this aligns more with that because it's less straight formulaic, right? They can't just type the full formula into their calculator. This is what the STAR item writers are leaning towards, unless that is shifting. And with new legislation and potentially a new test in a couple years anyways, might not matter, but for now.
It makes me think like, I know in the 7th grade test, do they do it in terms of pi?
They do not because they don't
have
look,
any cylinders.
they don't, yes, they don't have the round shapes. So that's
no
unique
sphere
to,
circles at all in 7th grade?
if we go back to looking at that T.
I know not in that T, but I don't know if like for surface area, I thought cylinders is
For
part of
surface
it.
area, they have cylinders, but they don't have anything for volume.
Like for surface area, do they do it in terms of pi? Because that would be easier for 7th grade because they don't calculate it.
Yeah, that would be easier for them to do, but I don't know if it has it in 7th grade, like in terms of pi.
Sorry to get off.
No, that's something we can explore when we address the surface area stuff later. Okay. So this question here, the volume of a cone is approximately 1,647 cubic centimeters. The height of the cone is 13 centimeters. What is closest to the diameter of the base of the cone? So we were only at 27%. This is a challenging question. The good news is, I mean, 24% of kids chose B, so they found the radius correctly, right? They just didn't double it to get that diameter, but this is definitely a challenging.
Was this like a question mark question?
Yeah, it was an exclamation point one.
Point question, you know?
I do not.
I'm curious, cause that's rough.
So they gotta work.
No, that was not. Was not one of those. That's crazy. Dude.
And again, like, I feel like it's like solve problems. I guess it does involve.
Yeah, I think if we break down that teak, if it had just said calculate the volume of cylinders, cones, and spheres, these last two questions wouldn't even apply, right? This question is specifically goes with involving that volume.
Yeah.
So they really do need to know how to
Work backwards.
rearrange that formula. So their equation solving skills need to be strong.
Sheesh.
1/3.
It's a lot.
Cause like, at this point in the year, we haven't talked about like square roots or anything. So like, I could even, like we've even done like the real number system.
Dude, that is hard.
Yeah.
That is
Like
hard.
they, all right, it's a cone, so they gotta multiply it by 3 and divide it by pi, and then find the square root, and then double it.
So knowing that you haven't addressed all the skills that they would even need to be able to do a question like this, is that something that,
No, I think the answer choices show you like, all right, 25, 25, 25, 25, pretty much. That means, all right, everybody guessed.
Yeah.
Everybody.
I'm sure they're like, oh, a volume one, this one's gonna be easy. They're like, what is this?
So the other question is, this could also come down to test taking strategies.
Yeah.
Let's say a kid doesn't know how to work backwards, they don't have the math
Just
skills
plug
to
those
be
in.
able to square root.
That,
Yeah, could they have just plugged them in?
They could have.
that's what I would have to do. I think
That would have been the easiest route.
easier way to do it. Like, alright, well, 22 is the diameter.
You can plug it in.
I'm gonna just see something for
Okay.
my own self real quick. Like,
I know, I was like, I'm just gonna use the
My brain doesn't calculate as
calculator
fast
on
as
my
Freeman's
phone.
there.
Can
cone
I?
1/3.
Alright, so I'm gonna do
It's 1/3 pi r squared times height, right?
squared
Mhm.
times pi times 13.3. That's 1647.241748.
Do you think that also throws them off? Is that it's approximately, it's not even an exact?
Yeah.
I think I need to talk about that more. Be like, is this the exact area or volume of this stuff? No. 'Cause
It does say
we're
closest.
rounding it, right? So I know it's not exact. Because pi goes on forever, we can never find the exact.
I can say kids don't really know how to round once they get to high school. Like,
They don't.
goodness.
I observed a kid, multiple kids, they think that it has to be 6 or more to go up one more, not 5 or more. Not sure where that misconception is originating, but they don't understand the approximations. Okay, I don't want us to get bogged down on this question, so let's go ahead and look at that supporting standard. Okay, so last year the test was describing a swimming pool in the shape of a cylinder. Okay, it tells them the diameter, it does tell them the height very explicitly, and asks them to complete the equation that represents the volume.
They should be able to do this.
Yeah, I would.
Last week we practiced that like a million times. We drag and
I
drop
mean,
and
if you
shit.
use
That's
the
how we taught
diameter,
it.
you die.
So you ready for your data?
And I hope it's good.
It's not gonna be good.
Alright, so 42%-ish of all students got full credit. 42% got, or 41% got half credit, meaning they got one blank correct, one blank not correct, and then 16% missed it completely.
I wish I could see how many kids put 7.5 rather than 7.5 squared.
Yeah.
They go, oh, 15 divided by 2 is 7.5, and the height goes in.
Unfortunately, there's not a way for us
I
to
know.
see that
Yeah.
unless you log into each kid's individually, but
I wonder if
I
they
bet
put them in
it's-
the wrong spots, if it's still.
it does not count it wrong in this situation.
Okay.
If it's a mathematical equivalent, it'll
Okay.
count it correct in either.
And you know what I mean too? Like here, it's like, okay, you practice big B, right? You practice pi r squared, pi r squared, pi r squared, pi r squared.
Mm-hmm.
And now it's like, alright, just do r squared. That's it. Like, I mean, it's just crazy. It's crazy how many different ways. There's a million different ways, right, to test it.
There are.
There's a million different ways. So it's like, I don't know. I mean, I'm just like, every year it's crazy because, I've been teaching the same class for 16 years. And it's like,
Like, I would never thought to teach them that.
I would never, every year there's a new way. You know what I mean?
Yes.
I do feel like we taught it very close to this though, like
Yeah.
especially when it came to us doing our spike time with Star, like they had to rewrite it in their little blocks.
Yeah. I mean, 83% kind of knew what they're doing, right?
Yeah.
I was like, and like, I'm really hoping that most of those kids who got half credit didn't put the square.
And what's cool is they could have put the
Yeah.
answer in either box, right? They could have put
Yes.
They could have put the height in the first box or the height in the second box, and it would still be right. The way
Yeah.
that it's set up, they have the benefit of putting it in either box.
Mhm.
But
And I feel like this is something easy to incorporate into practice.
yeah,
Yes.
And I think incorporating this type of thing into practice, even with, these types of questions, any volume formula where it's set up, okay, plug in your pieces. Now what do we do? Can we simplify it into pi?
I don't know. I think it's still going. It's still going.
Yeah, the green one's still. Okay.
Yeah, I'm on board with doing them in terms of pi. I think that's gonna be. I think selling that to them is gonna be easy to sell.
Good, that's one less thing we gotta do. Oh.
Yeah.
Yeah, you
know
want it to be
exactly
easier?
what it is.
So the last thing we need to touch on before we run out of time is how can we support our emerging bilingual students specifically in this unit, right? We're trying to encourage them to talk more, okay? And trying to encourage them to write more. So what is an easy question that you could have a sentence stem or a vocab wall, something of that nature, to where you could get them talking about volume? Because if you look at past years of TELPAS, volume style questions, not where they're doing the math, but they need to understand what the concept of volume and what the concept of surface area are, have appeared more regularly on TELPAS within the last few years. So something they need to do is understand really what that is as a concept.
Like my initial thought was just like have them like have like a sentence stem where it's like, I'm going to use
Fill in the blank.
blank formula because this shape is a blank. So they gotta use the right formula, so they gotta say the formula, and they gotta say it. So they gotta be able to recognize the shape, and then look at a chart and find the right formula.
I think that's a great idea.
Yeah.
And like I always try to emphasize that volume is like how much I can fill it up, and surface area is the outside.
Mm-hmm.
I feel that with the fill in the blank, although it may not spark up as much conversation as we would like because they're filling in those blanks, it still is really helpful for them to grasp what we're trying to teach, especially with the repetitive,
Yes.
constantly doing it.
Well, like even today, I give them all a formula chart, and I'm like, okay, we're gonna do area of a circle today. Does anybody know what the formula is? Pi times diameter, right? I'm like, no. Go to area, and then go to a circle, and then tell me that formula, right? So it's like, as stupid as you think it is, it's like they find the first place it says circle,
Mm-hmm.
and they tell you what they see. So it's like, okay, you've got to practice looking at the formula chart and finding the correct formula. So I mean, that's easy to do. I think that's easy to do. Like, put a picture of your formula chart, give them a shape, have them click on what they're supposed to click.
And I really think improving performance on this teak or these teaks, minor changes, right?
Yeah.
Incorporate practice where you're leaving it in terms of pi, practice plugging it into a broken down formula like this before they put it in their calculator.
Yeah.
Easy fixes with big gains.
Yeah, we've been doing stuff like this with those labeling ones.
Yeah.
Today with like the circles, I made them like
I
they
just
like,
made one like that,
they
exactly like
they,
that.
they had to show me what they're gonna type in their calculator before they could actually type in their calculator.
I like
no,
that.
they had
I
to.
like how you did that.
I thought
That's
that
the
was
one
good.
for.
What is the formula
Yeah,
you're
so-
going to type in? Now,
Yeah.
what is
no,
the answer
no,
after you
type
type it in?
And they'd tell me what's the radius, what are you gonna type in your calculator, like what is the formula using the radius, now what is the actual answer, they'd put all three, so get them to do all three every time. Like when we did simple interest, they made them find the interest and the total every time. But then I'm like, hey, on the test, it's when I ask for one or the other, they're simply got used to finding the total every time, that they're like, oh, it's the interest, I don't have to do the extra part. They did really good.
Yeah.
So it's getting them to show their steps, doing those labeling ones have been really cool. I really enjoyed that.
That's awesome. Well, I think that's all we have time for today. Thank y'all for being here. I know looking at data is not always fun, especially when it's not necessarily what's been our strength, right? But if we look at y'all's overarching data, remember, y'all are the rockstar team on campus. Your data on the majority of the readiness standards.
And I feel like
Knock it out of
it
the
was
park.
the year before, and then just those question types that it's probably on us that we didn't.
Yeah.
I would not have done.
Yeah.
I wouldn't have thought to do it that way. I've been like, oh, we're just finding the shape, plugging it in. It's so easy, and it is, but we gotta go a little deeper apparently.
Mm-hmm.
I think that'll be great. Thank y'all
Easy
again.
fixes.
Yeah.
No, I think we got good ideas. I think
Yeah.
so.
I need to be easy fixes some of the stuff we're already doing. It was already a strength. Now we're gonna bring it back.
Let's do it.
Come on.
I like it.